Okay. The recording is started and the door is closed, so it is a win today. So the first thing that we're going to talk about is we're going to talk about simplifying. And what I have right here is I have a fraction. I actually have two fractions. I have 18 over 24 and negative 36 over 63. You have been asked to simplify these before. And how do I simplify 18 over 24? What do I ask myself? What number goes into both? What number goes into 18 and what number goes into 24? And what is that? 6. Okay? So an even better question might be, what's the largest number that goes into both 18 and 24? And so the answer to that is 6. And so what I'm going to do is I'm going to ask myself, 6 goes into 18 how many times? And 6 goes into 24 how many times? 4. So 18 over 24 simplifies to 3/4. Now, did anyone say to themselves, oh, 18 over 24, both of those are even, the number 2 goes into both of those. Did anybody think that? It's okay. It's okay if you did. Okay, so then immediately you say 18 divided by 2 is 9. 24 divided by 2 is 12. Now, it's fine if you do that as long as you ask yourself again, can this be simplified further? Can 9/12 still be simplified? The answer to that is yes, it can. What goes into 9 and 12? 3. So then I simplify that further to 3/4. And that is okay, but you definitely want to get into the habit of saying, can I simplify this further? And that's something that you're going to want to do on all of these. Now, the next one, negative 36 over 63. Negative 36 over 63. Okay? 9. Correct. 9 goes into both of those. Okay? 9 goes into 36 4 times. 9 goes into 63 7 times. What is it that students forget on this type of problem right here? The negative. Over and over and over again, students forget that negative. So be careful with that, especially as we start adding lots and lots of variables. We end up forgetting that negative. Okay, the next one. Now we're going to start putting variables into it. We're going to start putting variables into it. Now, every one of these are a monomial divided by a monomial. We don't have any binomials and we don't have any trinomials. We are only dealing with monomials. Monomials are all multiplied together. They're all multiplied together. They don't have any addition and subtraction. That's what a monomial is. So we can treat those the same way that we treat numbers. So in this one right here, I have 15xy over 25y. 15xy over 25y. What you want to do is you want to deal with the numbers first. You want to deal with the numbers first. So what number goes into 15 and 25? 5. So 5 goes into 15 3 times. 5 goes into 25 5 times. Now I focus on the x. Is there an x in the top and the bottom? No. So I leave the x alone. Now I focus on the y. Is there a y in the top and the bottom? Yes. Okay? So I am able to mark that out. So my answer here is 3/5 x. Now, I want to talk about the way that negative 4/7 is written and the way that 3/5 x is written. Where do I have my negative sign right here? On the top. Okay? Now, you can have your negative sign, and how I write it, I almost always have my negative sign in the numerator. Whenever something like that happens, I just move it to the numerator. Okay? I'm very, very consistent about that because that helps keep things straight when you have to distribute. Because sometimes you're going to have to distribute that negative, And if you just move it to the numerator, you're not going to accidentally do 2 negatives. Okay? So you will see me very consistently write the negative in the numerator. But I want you to realize, I can write it in the numerator. I can also write it in front. Do you see the difference between those two right here? This one is definitely in the numerator, and this one is right here in front of the entire fraction. Both of these mean exactly the same thing. Now, you will see it less often. You will see 4 over negative 7. All 3 of those mean exactly the same thing, and all 3 of those are correct. Okay? So I want you to realize you can put that negative sign anywhere. What's the one thing you can't do? Take it out. Yep, you can't take it out. There's something else that means different.
Put it on both.
Yes, correct. Put it on both. Okay? So I'm going to write not okay is for you to do negative 4 over negative 7. Now, the place that we see this the most often is in slope. Okay? When we do linear stuff and we're subtracting points and your x's and your y's and all that, that's where I see the most mistakes on this. But I like to bring this up when we're talking about this, about what this means. Now I want to talk about this x. The rules for the x are not the same as the rules for the negative. So in this particular problem, my x is in the numerator. It simplifies, and I am left with an x in the numerator. So it is okay for me to write the answer as 3x over 5. It is also okay for me to write 3/5 x. But I want you to look at that 3/5 x very carefully. Okay? This x is right beside the line. This x is clearly in the numerator. Both of these are okay. What is not okay is for that x to be in the denominator. So you can't have 3/5 x. That means something different. The value is different. The most often thing I see is that right there. That is wrong. The value is different. Now, when we first start doing it, a lot of times when we start our linear stuff, you'll see me do something like this. Okay? I'm trying to get you to write that x up. But I want to prove to you why these are equal and this isn't. So, if I take 3/5 x, and I'm going to erase some of my negative stuff over here. So I'm going to erase all this. So, what I've got is 3x over 5, and I've got 3/5 x. And I'm going to evaluate for when x equals 2. So what I'm going to do is I'm going to take this 2 and I'm going to plug it in for the x in both of these. That's what I'm going to do. So on my first one, I have 3 times 2 over 5. What's 3 times 2 over 5? 6. Did I make a mistake? Oh, okay. Sorry. I thought people were laughing at me. It's okay to laugh at me. You just got to tell me why you're laughing at me. It's okay. Or don't laugh at me. I don't care. Okay. Then I have 3/5 times 2. What's that 2? It's 2 over what? 2 over 1. 2 over 1. Okay? And 3/5 times 2 over 1 is 6/5. Now, I'm going to take these two. So I have 3/5, and the x is in the denominator. When I plug 2 into that, what do I get? 3 over 10. Is that the same thing? No. Okay? So that's why you've got to be careful numerator and putting the x in the denominator are not the same thing. So again, where is it safest to put your x? Yeah. Because sometimes we start writing, I see this all the time, right here. See it all the time. So be careful with that. I haven't taken off for that. But eventually I have to because we've got to keep that straight. Okay, let's look at our next one. We have negative 28a squared b squared over negative 63a squared b to the third. I want you to deal with the numbers first. So I've got negative 28 over negative 63. I have a negative over a negative. So what's that going to be? A positive. Okay? Negative over a negative is going to be positive. What number goes into both 28 and 63? 7. Okay? So 7 goes into 28 4 times. 7 goes into 63 how many times? 9. Okay, now I have an a squared on top and an a squared on bottom. What happens to my a's? They cancel. Okay, so they're gone. A squared, a squared. Now, I have b squared on top and b to the third on the bottom. Let's think about what does that mean. B squared means b times b. B to the third means b times b times b. So when I cancel these out, what am I left with? Where? On the bottom. Good, I'm left with just b on the bottom. So what we just said about all that is important because if I put that b on the top, does it mean the same thing? No, it doesn't mean the same thing. Okay? So 1 over 2 is very different than 2 over 1. And that's why this is like this. Now you can still subtract. So we're left with b to the first. But I want you to realize that the variable stays wherever the exponent is highest. So if I had b to the third on the top and b squared on the bottom, then my b would be in my numerator. But here, my b to the third is on the bottom, so my b stays wherever the highest exponent is. Yes, ma'am?
And you can't forget to bring down the negatives.
I'm sorry?
You can't forget to bring down the negatives.
Yes. Now, in this situation, a negative over a negative is a positive. But if I just had one negative, like I did with 4/7, that is super important. You got to bring down those negatives. Excellent. Okay. Now, again, I want to point out that all of these are monomials divided by another monomial. We are simplifying two monomials that are being divided. Is what we're doing. We're simplifying that. Now, I want you to look at what we have here. Okay? Now I have a binomial divided by a binomial. So I've got my addition and I've got my subtraction. Here I have a trinomial divided by a binomial. The difference in what we're looking at now is that inside the numerator, I've got addition or subtraction, and or in the denominator, I have addition or subtraction. When that happens, you absolutely, without hesitation, have to factor first. Okay? Before we do anything else, we've got to factor. Okay? So, x squared plus 4x divided by x squared minus 16. I'm going to give you 1 minute. I want you to factor that. You've got a GCF to take out at the top. You've got difference of perfect squares on the bottom. GCF in my numerator? X. So that's x times x plus 4. What's going on in my denominator? Good. Difference of perfect squares. Okay? Difference of perfect squares is x plus 4. Good. What you want to focus on here is that you've got to factor. And that's what I did. I factored. I have x plus 4 in the top and x plus 4 in the bottom. I can cancel that out. The entire binomial has to be the same. The entire binomial has to be exactly the same. So I am going to cancel my two x plus 4s. I'm left with x over x minus 4. You have to think about that x minus 4 as a unit. X minus 4 is different than just x. Students want to cancel these two x's. You can only cancel something that's being multiplied by something else. The entire, if it's added or subtracted, you can't do that. It's got to be a factor. My factor in my numerator is x. My factor in my denominator is x minus 4. They are not exactly the same, so I cannot cancel those. Okay, so x over x minus 4 is your final answer. Okay. Now, 6a squared minus 7a plus 2 is a trinomial that we know how to factor. So I'm going to give you 1 minute to factor that. Okay? Factor that. Okay, so 6a squared minus 7a plus 2. I'm hoping that you guys got this. We just had a test on this. Factoring is so important for this chapter. 6 times 2 is 12. So my product is 12. Negative 7 is my sum. The two numbers that I break that down to are negative 3a and negative 4a. Then I factor by grouping. 3a comes out of both of these. Negative 2 comes out of both of those. So I have 3a minus 2 and 2a minus 1. My denominator, I have a GCF. What's my GCF for my denominator? 5 and? Good, excellent. Okay, so then I'm left with 2 minus 3a. Now, at first glance, it appears that you cannot simplify anything. But we have something that looks similar. They're not exact, but they look similar. What looks similar? Good. 3a minus 2 and 2 minus 3a. It looks similar. What you need to realize is when you have something like that, 2a minus 2 over 2 minus 3a, that equals negative 1. You can simplify that to negative 1. So if I multiplied everything here by negative 1, I would have what I want. So what I want you to do is I want you to look back at 10a minus 15a squared. What do we notice about that? How is it written, and how is it written differently than what we're used to? What are we used to seeing?
15a squared minus 10.
Okay. We are used to seeing the a squared first. Okay? In this situation, the 15 associated with that a squared is negative. So I have to keep that negative with it. Okay? So all I'm doing, I'm taking 10a minus 15a squared, and I'm going to rewrite it as negative 15a squared plus 10a. Have I changed the value of that at all? No, it's exactly the same. My positives are with my positive 10 stay positive 10, my negative 15 stay negative 15. When you rewrite it like this, and traditionally we always see our squared value first. When I write it like this, it clues me in that taking a negative out might be a good idea. So instead of taking 5a out, I want you to take out negative 5a right now on your paper. Take that out, negative 5a. When I do that, what do I get? So I have rewritten this in standard form, and I took out a negative instead of a positive. What is this right here? 3a. It is wrong, is what it is. You can tell me that. Okay, what should it be? 3a what? Minus 2. Okay, and that's because negative 5a times negative 2 gives me positive 10a, which is what I need. So when I write this up here, taking out a negative 5 instead of a positive 5, what do I now have? What can I do with the 3a minus 2? Cancel them out. I can cancel them out. Okay? Because they are now exactly the same. So your answer to this is 2a minus 1 over negative 5a. Now, I will tell you, the back of your book will have that negative in all sorts of places. Okay? But if you get there and you feel like you've done it right, but yours is slightly different from the back of the book, there's a decent chance that you are right. You know how I said I always move my negative to the numerator? Move it to the numerator, you've got to distribute it. So then it becomes negative 2a plus 1. That's what the back of your book says. The other thing that might happen is this negative might get moved right here. Okay? That's also acceptable. This answer right here is 100% correct. You will get full credit for that. You will also get full credit for this. Okay? Now, the other thing that you will get full credit for is moving that to the numerator. But if you move it to the numerator, you've got to distribute it to the whole thing. So that leaves you with negative 2a plus 1. And then it's written 1 minus 2a over 5a. I know I'm running out of room there. Okay? Moving it to the numerator, students end up making a mistake because they don't distribute it to both. They only put it in front of the 2a. So it's dangerous to do that in this situation. I would leave it right here. This is simplified. This is perfect. But when you move that to the numerator, you've got to remember to distribute it. And that's going to be important when we do subtraction on Tuesday. But it's super important that when you move it to the numerator, you're distributing it. Okay. Any questions on simplifying? Okay. What we are going to do now is we are going to multiply and divide. So we're going to multiply and divide. So now I want you to think about, how would I multiply 2/4 times 4/5? How would I multiply 2/4 times 4/5? Multiply across the top and then multiply across the bottom. Okay? I would end up with 8/20, and 8/20 simplifies to 2/5. Okay. That is a reasonable way to do it. What I want you to get in the habit of doing is, I want you to get in the habit of cross canceling. Okay? Cross canceling. It is so valuable to cross cancel once we start doing with all these variables. Now, something else that I want to point out. When we are multiplying and dividing rationals, and rationals are just fractions with variables thrown in. That's what a rational is. Fractions with variables. When students see fractions, doesn't matter if we're doing multiplication, division, addition, or subtraction, students immediately think, oh, I need a common denominator. They immediately think that. When do you need a common denominator? Only adding and subtracting. Yes. Okay? So when you see this, you only need common denominator when adding and subtracting. You do not need a common denominator when you're multiplying and dividing. So we don't do common denominators until Tuesday. Okay? This we cross cancel. So what I'm doing is I'm looking at my 2 and my 5 and my 4 and my 4. Is there anything between the 2 and the 5 that can be simplified? No. Nothing goes into 2 and 5 equally. However, when I look at my 4 and my 4, can those cancel? Yes. Okay? So I am going to mark out my 4 and mark out my 4. So I am left with 2/5. Okay? Cross-canceling is very, very valuable because you are dealing with smaller numbers. And the smaller numbers that we deal with, the less likely that we'll make a computation mistake. So you do want to use this cross-canceling method. Okay? Now I've got 3x over 4y times 8y squared over 9x. We are still going to cross-cancel. So I'm going to look at my 3x and my 9x, my 8y squared and my 4y. Now, think about the numbers separately from the variables. So look at the 3 and look at the 9. Is there anything in the 3 and the 9 that can be simplified? 3. 3 goes into 3. 3 goes into 9. 3 goes into 3 one time. 3 goes into 9 3 times. Okay? Now look at your x and your x. I've got x to the first and x to the first. Can I cancel those? Yes. So I am just going to mark them out. Okay? Now I'm going to look at my 8y squared and my 4y. Focus on my numbers first. What number goes into both of those? 4. Okay, 4 goes into 8 twice. 4 goes into 4 one time. Now, I have y squared in the numerator, and I have y in the denominator. My y in the denominator simplifies out. What am I left with in the numerator? Just y. Okay? So I mark out the 2. Now, I have 1, 2, I have all that left. So I have 2y in the numerator. Where am I? There I am. And then I have 3 in the denominator. Students sometimes lose numbers in variable and all the crossing out. So be careful with that. Be careful with all the different crossing out. Some students use different colored pens or pencils. Some students use highlighters. Okay, if you use a Sharpie marker, don't write on the back, please. So be careful with that. You can bring different color markers to tests if you want to. Yes, yeah, and highlighters are good. Anything that you want to use is fine, except, your phone. Okay, here we go. Now, we've gone from monomials. So we've got a monomial over a monomial times a monomial over a monomial. Now we're going to bring binomials and trinomials in. Once I bring binomials and trinomials in, what do I have to do first? Factor. Factor. Okay? I have y over x squared minus 4 times x plus 2 over y squared. I'm factoring. So we're back to factor first. Factor first. X squared minus 4 is the only one that you've got to factor. So please do that now. Factor x squared minus 4. Okay. So I have a y here, and I have a y squared here. I can simplify this y out, and what am I left with here? Just y. Okay, now. So this y is gone. This y, the y squared becomes y. Now, what is left right here? What is left? Okay, I've got nothing. I heard something back here. Okay, we are going to have x minus 2, and that's going to be in the denominator. So you're right about that. What's left in the numerator? It is a 1. It is not a 0. Students think that when we cancel everything out, that it's a 0. It's not a 0. If this y right here was the number 2, if this y was the number 2, and I said 2 goes into 2, how many times? What would I have left right there? A 1. Okay? What I have done right here is I've said y divided by y. What is a number or a variable divided by itself? 1. Always. Okay? Be careful with that, because I always have students that will end up putting 0 there, and it's not 0, it's 1. So I'm left with 1 right here. Okay? Then my x plus 2 and x plus 2 cancel out. So in my numerator, I'm left with 1. Then I have y, because I've got a y right here, and x plus 2. Now, if you wrote that as y over x plus 2, thank you. Thank you very much. X minus 2. Okay, both of these are correct. What is not correct is that right there. Okay? You've got to have that x minus 2 in parentheses. You've got to have that in parentheses. Okay? Now, this one is more intense. This one is more intense. So the first thing that we're going to do is we're going to factor everything that we can factor. So I'm going to give you 3 minutes to factor this. 3 minutes to factor this. Okay, the denominator there, x to the 4th minus x squared, might be more difficult. So I've done that off to the side. Yes, so the one that I circled, that x to the 4th sometimes confuses students, so I just went ahead and pulled it out. And so I did x to the 4th minus x squared, pulled an x squared out of both of them, got x squared minus 1, and that's a difference of perfect squares. That's what that is. So in red, that's the denominator to the second one. Okay, so I'm hoping that you are comfortable with factoring. Okay, factoring is what we spent all of chapter 3 on. If you're not comfortable with factoring, then we need to talk. We definitely need to talk, so you need to come see me, because factoring is not going away. The numerator, x squared minus x. X squared minus x. You pull an x out of both of those. So I've got x times x minus 1. X plus 5 can't be factored. It's a binomial. X squared plus 5x plus 4. My product is 4. My sum is 5. X plus 4 times x plus 1. Underneath, I've got x to the 4th minus x squared. And I wrote this one out in red. X to the 4th minus x squared. X squared is common to both of those. Then I'm left with an x squared minus 1, and that's a difference of perfect squares. So I've got x squared times x plus 1 times x minus 1. Okay, now, if it's in the numerator and the denominator, I can simplify it out. So again, I always start kind of looking at my cross cancel. So I have x minus 1 and x minus 1. I have an x here. I've got x squared in the bottom. So what does x squared become? Just x. Good. Okay. Now, x plus 4 and x plus 5 doesn't simplify. Okay, so I have to leave that. Do you see how I've got an x plus 1 here and an x plus 1 here? That can simplify. It's okay to simplify it with it on the same side. So I'm going to mark that out. So in my numerator, I'm left with x plus 4. In my denominator, I have an x. Right there, I've got an x. And then I've got x plus 5. Okay? It's not a terrible idea to get into putting that binomial in the numerator around parentheses. If you don't, it's okay because there's only one binomial there. Some students like to multiply that out on the bottom. I typically don't multiply it out on the bottom. I leave it like that. Okay? That is multiplying. When you get stuck on multiplying rationals, go back and think, how do I multiply fractions? Think about, how do I multiply fractions? Okay? Now, we are going to divide fractions and rationals. So let's look at this right here. 7/8 divided by 5/6. 7/8 divided by 5/6. Take a second and think about, how would I divide that? How would I divide the fraction? Anybody remember keep, change, flip? How mathematical of it, right? There's nothing about that that's mathematical. It is an acronym that helps us remember what to do. We keep the 7/8, we keep it the same. We take our division sign and we make it what? Multiplication, and we flip the second fraction. Keep, change, flip. Okay? So I have 7/8. My division becomes multiplication, and I flip the 6/5. Or the 5/6. I flip it, and I get 6/5. Now, students want to skip that step, or they want to skip writing down the original problem. Do not skip steps. I know that you think you can do it in your head, but you can't. And if you do it in your head, there's significantly more opportunity to mess up. Don't skip that step. Okay? Don't skip that step. So I keep, I change, I flip. Now I have a multiplication problem. So what I'm going to do, I'm going to look here. I can't simplify anything. I'm going to look here. My 2 goes into both of those. 2 goes into 6 3 times. 2 goes into 8 4 times. 7 times 3 is 21. 4 times 5 is 20. Now, 21/20 is what we call an improper fraction. An improper fraction is when we have a bigger number on top than we do on the bottom. This number could be rewritten as 1 1/20. I don't want you to do that. I want you to leave it improper. Improper is okay, but, so this is okay. This is an improper fraction. Okay? Let me think. 9. 15 over 6 is also an improper fraction. The fact that it's improper is not the problem here. The problem here is that both of these are divisible by 3. This is improper, but it's not simplified. So if I get 15 over 6, I still need to simplify that to 5 over 2. Okay? So it's okay to get an improper fraction, but be sure you simplify if that improper fraction can be simplified. Okay? I just made 15 over 6 up. It doesn't have anything to do with that problem. So we would need to change that to 5 over 2 because 3 goes into both of those. Improper is okay, but make sure your improper is simplified. Okay, now we're going to do the same thing. Do not skip this step. We are going to keep, we are going to change, and we are going to flip. So we're going to keep, we're going to change, we're going to flip. Okay. I have 16x squared y over 24x y to the third. I write it down exactly the way that I have it. My division sign, I turn to multiplication. My 8x squared y squared goes to the numerator. My 9xy goes to the denominator. I have flipped. The mathematical term for that is reciprocal. The mathematical term for that is reciprocal. Okay? Now, I look at numbers first. I have 16 and I have 9. Does anything go into 16 and 9? No, you're thinking 18, but no, it doesn't. Okay, so my 16 and my 9 have to stay tight. Okay? What about my x squared and my x? What happens? Okay, my x squared becomes x. So I am canceling this one down here, so that makes my squared just become x to the first. What about my y? They're both gone. Okay? Now, what number goes into 8 and 24? 8. 8 goes into 8 one time. 8 goes into 24 3 times. I have x squared on the top and x on the bottom. So this x goes away. What does that x squared become? Good. I have y squared on the top and y to the third on the bottom. My y squared divides out and we get 1. What does my y to the third become? Good. Now, I have 16 times 1, and then I have an x. So I have a 16 here, I have an x, and then everything in my numerator here became 1. So I just have 16x times 1. Nope. Where's my x squared?
The x next to the 8.
Okay, yes. So I have x times, there's my x right there. I knew I had an x squared, I just couldn't find it. That's what happens. You lose things in all your work. So I have 16x squared. In the denominator, I've got a 3. I have a y hidden right there. And then I have a 9. So in my denominator, I'm left with 27y. When you get to this point, you have to pause again. Pause right here and say, can anything else be simplified? Did I miss something? Is there a 2, a 3? Is there something that goes into both of those? Do I have some variables that can still be simplified? So pause here and make sure you've done it. And just like I lost that x right there, with all this marking out, it's super easy to lose a variable or a number in all those different colors, or all the different marks. They're easier to find when you've done it with different colors, but still you can lose them, so be careful. Now, here, we've got a monomial divided by a monomial, divided by another monomial over a monomial. Now we're moving from that, and we've got binomials and trinomials again. Okay? So, what's your first thing you do? I was going to say factor, but keep, change, flip is better. We need to do that first. So we keep, we change, and we flip. So I have 3a squared plus 12 divided by 3a squared minus 15a, multiply a squared minus 3a minus 10 over a to the fourth minus 16. Now what do I want you to do? Factor. I'm going to give you 3 minutes to factor. Both of these right here are GCS. You're factoring out a GCF. Pretty straight trinomial. This one might be confusing, so I'm going to do that off to the side so you can see it. Okay, a to the fourth minus 16, that's a difference of perfect squares. A squared minus 4 times a squared plus 4. That has to stay a squared plus 4. You can't do anything else with it. This is another difference of perfect squares. You know how to factor that. We've got all the factoring. My 3a squared plus 12, I can take a 3a out of both of those. I'm factoring out my GCF. I have 3a times a plus 4. Here I've got 3a squared minus 15a. 3a times a minus 5. A squared minus 3a minus 10. My product is negative, so I'm going to have one positive, one negative. My sum is negative 3, so that means it's negative 5 and positive 2. A to the fourth minus 16. I know that one might have been a little bit challenging. It is a difference of perfect squares. A squared minus 4 times a squared plus 4. A squared plus 4 you've got to bring down. I know that's a little hard to see, but you just bring it down. A squared minus 4 is another difference of perfect squares. Okay? Again, if you're struggling with factoring, come talk. Okay, here we go. If it's on the top, and the bottom, we can simplify it. I can go ahead and simplify the 3a over 3a. Even though it's not cross-canceling, this is in the numerator and this is in the denominator, so it can cancel out. Okay? I have a plus 4 and a squared plus 4. Those are not the same thing. Yes, ma'am?
How did you get 3a out of the numerator?
Oh. Yeah, you're right. You are absolutely right. The only thing I can take out of that's a 3. Okay. So then I'm left with a squared plus 4. Thank you. Thank you very much. Okay, so that makes a difference. Here, I can cancel these 3's only, not the a. This a squared plus 4 and this a squared plus 4, they can cancel, which is good news. Okay, don't lose that a in there. That's a dangerous spot for it to be. Okay, then I have a minus 5, a plus 2, and a plus 2. What do I have left on the top? 1. On the bottom, what do I have left? A times a minus 2. Okay? That a is snuck right in here. And that's one that sometimes we forget. Whew. Are we good? Okay, I hope you guys have a great weekend. I will see you on Tuesday. This test will come faster than you're expecting. Okay? Just FYI.
When is it?
It'll be before we leave for spring break. But, I mean, we're at least 2 weeks out. But it's going to come a little because we're only doing about half the chapter. Okay?